Glad to see you all here today. My name is Jeff Burtoft, and I work at Microsoft, and that is actually Microsoft with an O in the soft. I don't know if you noticed on the schedule they left the O out. And I was thinking, it would be such a creative idea to have a company and name it Microsoft without the O. And then everyone would think that you're this huge company, but really just, spelled it wrong. But that's not what's happening here. This really is Microsoft. I'm really glad to be here with all of you today. Generally, on a day-to-day basis, I work with a lot of guys who write really boring programming languages like C++, something called C#, XAML, and all these things that isn't JavaScript. So I try to have conversations with them and talk about performance tuning and stuff like that, and they just don't get it. They don't know the world that we live in. So it's really great to be here today and to talk with all of you and to share some experiences here. So a little bit about myself. I blog at html5hacks.com, and I invite you to not go visit it this week because my partner on that site, we decided to start this site transition this week, and so I think we have like 2 of our hacks up there. But we will get the rest of the data as soon as we can figure out how to convert it from the one platform to the other. But we blog html5hacks.com, and what we did is we put a lot of those hacks together and then wrote a whole bunch more and worked with O'Reilly Media to put out the books, HTML5 Hacks. And HTML5 Hacks should be on the market. You can get the digital version now. The book should be on the market in just a few weeks. And we try to take these different HTML5 features and make them real, make them usable, and not just tell you about what the feature does, but show you a way that you can use it as well. On GitHub, I try to Twitter when I can, and you can reach me at Microsoft at jeffburt@microsoft.com. Okay, so who can tell me what this is? It's a ladder, right? It's a computer. We all know what this is. In fact, probably every one of us has one of these here with us today. We're very used to using computers, and as web developers, we're very used to writing code for computers. We know how to write for a keyboard. We know how to write for a mouse. In contrast, what's this? Well, this is a mobile device, right? And we probably all have one of these in our pockets as well. And we probably all have at least one of these laying around our house, if not 2 or 3, and we're generally used to writing code for that as well. Now, whenever we look at our code bases, and we're trying to write our code so that we can support both the desktop or the laptop, something that has a keyboard and a mouse, and something that supports touch, we generally write code that looks something like this. We do feature detection, which is good. I love feature detection. I love when we actually test to see if we support that feature before we try to run it. It's bad if you try to run it before you test to make sure you support it. Bad things happen to your apps. And even worse, I hate it whenever we make assumptions about user agents based on the user agent string as to whether they support something or don't support something. So I really like feature detection. And in this case, we're testing to see whether you support the on-touch start feature. And if you do, we use touch, and if you don't, we fall back to click. So in essence, we look at touch as an upgrade for click. So we're either going to attach our listeners for touch, or we're going to attach our listeners for click. And now we have this. And you probably haven't seen a lot of these around yet, and you're going to see a lot more of them. But these are Windows 8 devices. These are devices that are written for Windows 8. And if you notice something about them, they have both a touch screen and a keyboard and mouse. So if we go back to the way that we were writing code and we said, if you support touch, then use touch. Otherwise, fall back to click. Well, in this case, the user would have to choose one or the other. They're either going to use their mouse and keyboard, or they're going to use their touch screen. So we have a lot of these devices coming on the market today, and I'm going to talk a little bit about how we look at our event models for touch today and what we need to do in the future to make sure that we can support not only devices that work on a mouse or a touchscreen, but devices that work with a mouse and a touchscreen. So to get us started, I actually have a very handsome gentleman from Microsoft who did a little video in the office for us. He's stunning, I don't know what else to say. But he's going to do a little video preview here, and the sound for this is really bad, so I'm actually going to use this mic and just kind of play it through there. Sorry for doing kind of the ghetto sound here, but... And thank you to our amazing sound man for somehow making that work back. I did a really bad job of recording the sound there, so thank you. So I want to make sure that we saw that, because whenever we think about touch devices today, we think about mobile devices, we think about tablets, things that we can hold in our hand. But there's a whole slew of new devices coming out that are actually desktop convertibles like that. It's pretty amazing to work on a 27-inch touchscreen. A lot of times you think, well, what am I going to do with a touchscreen that big? But as soon as you just sit down in front of one, you start to figure out some really great ideas. Okay, so to take us back, I'm going to try to start at a place where we're all familiar. So the event model for a mouse. It's probably pretty familiar to all of us. We've been working with this for years. So it basically supports things like click, double click, mouse down, mouse up, mouse over, mouse move, type of things. And it works on our traditional mouse and keyboard devices, but also it works with our touch devices. A lot of our touch devices will fall back to a click. So what happens is you touch that screen, and if it doesn't register a touch event, it will fall back and then fire the click event, usually about 300 or 400 milliseconds later. So it actually works on your touch devices. Now the bad thing about it is it's not multi-touch. So you don't have two mice with two events at a time that you can do two things. So generally it's a single input environment. Now iOS has a great event model for their platform that supports touch start, touch end, touch move, and touch cancel. So that's basically, you put your finger down, and that's a touch start. You move your finger, and it fires the touch event, the touch move events, and then you lift it, and it's the touch end event. So this does support multi-touch. So on an iPad, I think it's up to 10 fingers that you can have on the screen at once. So it supports multi-touch, and it does not fall back to click. So if you have a touch event in your application, if you register a touch event, then it won't automatically fire the click event as the opposite happens. So if you have a click event on your page, touch will fire that, but if you have a touch event on your page, it won't fire the click. So basically, you can't use touch events on your desktop browsers. Now inside of the touch event, it has 3 collections. So the collections are kind of like live arrays of the touch points. So if it's something like this, and I actually think it might be easier if I just write it out and show you. So if inside of an event model that we're used to today, I can do something like event dot cancel bubble, or I can do event dot prevent default, and I can do event dot offset x, and inside of that event object, I'm going to have access to all of that information about the event. Now in an iOS event, you actually have event, and then inside of that, you have those 3 collections. So one of them, touches. Touches actually shows a collection of all the touches that are touching the screen at one time. So I'm going to then reference to a certain place inside of it, and then maybe go to something like client X inside of that. So it's event.touches.client.x instead of something like event.offsetX. Okay? So just so we understand that inside of this event model, there's a little bit of a different hierarchy that gives you access to all of the events that are touching that particular component, all the events that are touching the screen, and the third one is all the events that have changed since the last event was fired. Okay, so to kind of demonstrate, and I don't need audio for this, you guys are lucky. I have another little video, and what I'm going to be doing in this video is showing you 3 touch points on a screen. Each of those touch points has a different color associated with the position in the collection. Okay, so position 0 is red, position 1 is blue, position 2 is green. So I'm going to go ahead and play that. And now you see what happens is I'll lift a finger and then lift another finger. And as you change positions in the array, the color is going to change. So you can see the very top finger mark went from blue to green to red, but never actually left the screen. That's important to know because when we look at those collections, we don't want to look at the collection position as being the ID. Because there is actually an ID inside of there, there's a touch identifier inside of there, but the position can change at any time. So you don't actually want to rely on that to determine which touch point is which. Okay, you always want to go inside that array, all of that. So when we were looking at Windows 8 and IE10 and how we were going to work with touch to work on these devices that support a mouse and a touchscreen, we looked at some of the feedback that was collected about iOS Touch after we as developers have been using it for a few years. These are kind of the 6 points that we came up with here. So touch events are always viewed as an aggregate level. So you always have the arrays of the touch points. They don't have individual touch events themselves. They're all part of the same event object. So it requires different code to architect your application for an iOS mobile, so Safari on mobile, as it does for Safari on desktop. So what we end up doing is, what I kind of showed you at the beginning, is we write a lot of forward code. We say, if you support touch, attach these listeners and use this code. If you do not support touch, then fall back to click and write this code. The next thing is the delayed feedback to click. So I think it's a good idea that touch and a delay falls back to click, but it makes it a little difficult to handle both click environments and touch environments in the same application. We don't really want 300 milliseconds delay when a user touches the screen. We want the user to feel like they're controlling the application. We want it to respond as soon as their finger hits the screen, not 300 milliseconds later. So there's different touch models out there. So every browser has a bit of a different touch model. And that's a problem for me writing code, because now that fork in the code that we have for writing click versus touch is now forked again to support the different models. So there's no equivalent to a click. If you've ever tried to use a touch end instead of a click, you'll realize that there's there's not a clear equivalent one for the other. And it's not a likely candidate for standardization, okay? So about a year back, a draft was submitted to the W3C for touch move, touch end, touch start event models for standardization. And I'm gonna warn you, I'm throwing these articles up, and the media can be brutal. They have lots of link bait in their headers here, and say some really nice stuff, but the essence is Apple has IP around that touch model. And from a Microsoft perspective, I want users to support the intellectual property of Apple just like I would want them to support the intellectual property of Microsoft. But you can see that standard is actually going nowhere. So what now? And this is my son after eating some ice cream and losing his first tooth. And he asked me, he's like, well, what now? Dad, how do I eat? Because I don't have teeth. I said, well, buddy, you still have all your teeth, you're just missing one. For some reason, that was a crucial tooth to him. So what do we do now? If we can't standardize on that touch model, and we don't want to continue using click and only support one touch point, so Microsoft has developed a specification called the pointer specification, and it basically works like a click event. So if you came here today to learn how to use pointers in your applications, congratulations, you already know how to use them. If you know how to use the click model, you know how to use the pointer. Because it's the same model, the difference is the pointer allows for multiple touch points. So if we go back to that code that we were looking at before, and we say, okay, event.offsetX, that event object is going to work for any type of input, whether it's a mouse with a single input, or whether it's a touch with a finger, or a stylus touching your screen. So if you have a touch point or any pointer, you can have multiple ones on the screen. They're each going to fire their own event. So if you have an attach event with this function called test function on it, if I have 3 fingers on the screen, it'll fire that function 3 times. It would just be like 3 different mice on the screen. So if you know how to use that model, then you're going to know how to use pointers. So it follows the same pattern of our click event model, but it supports multiple touch points. So along with that, there's also some additional information inside of the event model that comes with the pointer. You have information, and this is going to be dependent on some of the hardware that supports it, like the width and the height of the touch point, so you can measure how high the touch point, how wide it is, pressure that you get from a pen or a tilt of that pen, rotation, pointer type. So I know from a pointer I can look at the type and say, okay, that's a finger that's touching the screen, or that's a mouse that's being clicked, or that's a stylus that's being used. Event type in many other attributes. So Microsoft has submitted the pointers as a specification to W3C, and they've accepted that specification. So I encourage you to all go and contribute to this spec, read through the specification, give us your opinion, give the W3C your opinion as web developers, what you do like about this, what else you want to see built into this specification, because we want to see this standard adopted quickly. And I'm going to go through some demos at this point and kind of, next slide. Go through some demos at this point and kind of show you how we work pointers in action, how we write code for multiple devices. So I'm going to start out with a demo here, and if you've ever wondered how many HTML5 logos on a screen are too many, here's your answer. So what I have here is I have a HTML5 logo being drawn over and over again on canvas. And we have a little bit of physics applied to this. And when I move my mouse on this screen, the mouse down, you can see it's going to follow and track my mouse. Now likewise, I have a stylus here, And this is a touchscreen laptop here. I'm going to move my stylus on the screen, and it's going to follow it just as it did for the mouse. And now I'm going to use my finger, and you can see the circle that's being tracked on my screen is my touch point, so it's following my finger as well. And there's some fun things here with this. But basically, takes a single pointer and treats the mouse just like it does the touch point, just like it does the stylus. So looking through some of that code, we actually have this, I have this working so that it does support both an iOS touch model, a click, and the pointer model as well. So when this app was first put together, we figured, okay, well, you're going to touch start, right? And then you're going to move your finger. So you're going to do a touch move and then track the touch move. That would make sense, right? Well, it turns out that was a really bad idea for performance. Back when JavaScript was slow, you could track an event because that event on a move would only be fired a couple times a second. Well, JavaScript's so fast now, when I do a move event, depending on my hardware, that can be called thousands of times in a second, that move event. So it was actually doing a whole lot of work that it didn't need to, because I was trying to respond to the screen when I moved my finger instead of when I was actually doing a drawing cycle. So what I had to do is take that code, and instead of tracking the finger on the move event and firing events on that move event, I instead took all of the pointers and moved them into an array. And that way, whenever I move my finger, all I have to do is update the array with the position of my finger. And I use the request animation cycle to read from that array. So my request animation cycle is running 60, 70 times a second here, instead of 500 or 1,000 times a second. So it's much more efficient to do it that way. So that's what you're going to kind of be seeing in this code here. So what we first do is we're looking at the set move method here, where we're going to be adding a move event. So when my finger down or my pointer down, I'm going to set this event, and it's going to attach the move event here. We're also setting up an ID for that array. So that array is going to have a position, and the position of each of those touch points is going to be its ID. Now, we're going to look at the iOS model, and remember how it has a collection which has positions in it, just like an array. So my first thought was, well, I can use those same positions to track the fingers in this array instead of building a separate array. But what I ended up having to do was actually go into each of those collections, go into my touches collections, and look at each of those touch points. So look at each of the fingers on the screen, because those, remember when we did that demo at the beginning where the colors changed? The position can change in your array based on what fingers are on the screen. So I couldn't trust the collection position that comes with the event model. So what I ended up having to do was basically go inside that collection, loop through that collection. If there was 3 touch points, I'd loop through it 3 times, and then take those touches and put their positions into a separate array. So it's actually a little bit more work to work with those active collections inside of an event than it is to work without them. So I'm doing a fork here, like we kind of showed at the beginning. I'm checking to see if you support touch, and if you do, I'm firing these events and using basically from my touches here, I'm passing in the position inside that touches collection. So instead of just passing in E, I'm passing in E.touches in the position. And if it's not iOS, I just call straight set move directly. So if you notice, I'm not actually forking it 3 times. I'm not forking it once for iOS, once for click, and once for pointers, because this second fallback of set move works for both a mouse click, your traditional click or mouse move, and also for pointers, because the models are virtually identical. The difference is, of course, the pointers adds additional data. So in this case, I'm just using the same code that I had written originally for a mouse, for mouse down and mouse move. I'm using that for pointers. So I'm writing it code once for iOS, once for everything else. So the move down here to the move touch point. The next thing I'm doing is I'm going and again I'm checking to see if I have that touches array. So if I have the target touches array, then I know that it's an iOS client here, and I'm again writing my loop and attaching each of those touch points to the array. Everyone else, I just directly attach those touch points to an array. So as we saw it work for a single input, it also works for multiple inputs. So I have 2 fingers on the screen here. And just, even though my code was really written originally for a mouse with 1 click, I can have multiple touch points and the same code works. So I didn't have to really make any changes to my pointer code or to my click code to have them work for pointers. I just pass in the pointer object instead of the click object, and instead of firing it once for a mouse, I'm firing it twice for 2 fingers. Okay, let's look at another one. All right, this is Brick Breaker. It's a fun little game that's written where you just basically hit your ball around. And if I can ever get it to the other side. Oh boy. All right, so I died. So anyways, what I have to do is move my mouse to the other side, and then I can control that as well. All right, so this game also works with touch. So I'm actually gonna, I did better when I wasn't looking at the screen than when I was. I'm actually gonna use my fingers here, 1 finger on each side, in the same model that I had for click. Works with touch here, and I'm playing my right hand with my left hand. So now I'm gonna go really right brain against left brain, and I'm actually going to use my finger on one side and my mouse on the other side. So I'm using 2 different input types at the same time. And the last time I tried to do this, I realized that when I try to go right brain against left brain, I realized that neither side of my brain worked very well independently. They really are reliant on each other. So I have 2 different input types. I'm using them at the same time. So this is kind of a cool demo, but it's actually going to be a reality for our users. It's going to be very, very common to be working on a touchscreen and then to lay that device down, flip the keyboard down, and use a mouse. So the way that we work with our code today, we do feature detection, and we detect whether we upgrade to touch or we downgrade to click. We make that decision at the beginning of the application when we write the application. So if, in that case, if we kept that same model and carried that model through to IE10 and Windows 8, then a user would have to make a decision when they loaded the page, whether they were going to use their keyboard or whether they were going to use their mouse. But we don't want users to have to make that decision. They should be able to switch back and forth between using a pen, using a keyboard and mouse, or using their touch screen, or any other input type of pointers that may come along in the future. So this is why we really backed pointers to make a really flexible environment for developers to write applications that work on devices where you don't necessarily know the input that they're going to use at the beginning of the page load. So with pointers, since that same event model works for a mouse, as works for a touch screen, as works for a stylus, you don't have to make that decision up front. All you have to do is write for pointers, and it's going to work on all those devices. So when you really look at touch, you realize that there are times when you want to define certain types of behaviors for touch and certain types for a mouse. There's times when your mouse may be more appropriate to do one type of user experience, and if they're using touch, do another. And that's one of the reasons why we have the type attribute inside of the event model, so that you can look and see what type of pointer it is that's touching the screen. So one of the ways that we have in place to be able to allow developers to create different experiences for a user, whether they're using a mouse or whether they're using a touch screen, is with CSS. So I have a couple examples here. This is a CSS carousel here, and the first thing I have is just a div with the overflow set to scroll. And as I touch the screen, scrolling over, if I'm using a mouse, it's clicking through basically the same way. Now, these are pictures from a trip that my family took to Mount St. Helens. Beautiful mountains, beautiful kids. Are there any moms and dads in the room here? All right, well, thank you for staying awake this long. Appreciate it. It's tough. That's the little guy at the end. So it's basically a scroll, but I want you to be able to stop at every picture. I don't want you to have to scroll over and then scroll back. So this is actually a JavaScript carousel that uses a jQuery, uses the jQuery library and a plugin. And as I swipe, it goes through each of those pictures. So it does pretty much what I wanted to do. One of the problems is it uses a lot of code to do that. I have to load jQuery, and then I have to load the plugin to do that. And the other thing is that it doesn't actually track with my finger. It's waiting until the swipe completes to fire a swipe event, a simulated swipe event, and then it switches pictures. So I'm going to scroll down to a pure CSS carousel here, and this actually just has, and I'll show you the code behind it in a minute. It just has a few extra CSS attributes added to it that lets it lock at certain pixels. So as I flip through here, this is just, again, a container with an overflow scroll. It stops on each picture, and more so, it tracks with my finger. So as I move, if I move back, it goes back to that picture. It's tracking directly with my finger. And I can show you these two together here. It's my two fingers. You can see the difference. One is tracking with my finger, one is waiting until after that event finishes to fire. So it's actually pretty simple to do that. Like I said, it's an overflow scroll container, and all I did is add these two extra attributes that handle the touch. It has the scroll snap type, and then I set the interval. So that's it. It gets for a really elegant touch experience that's different than what I'm using for a mouse and doesn't require any JavaScript to do that. So let's look at another one. Okay, same family trip. I love putting my family photos up there, it's fun. So this is Mount St. Helens, and I can move over, and there you can actually see the volcano there. I want to zoom in on this, so I'm going to use my fingers, and I'm going to zoom. And this is just an actual function of the browser here. It's going to zoom in. Well, as I do that, it's zooming in the whole page. Now in this case, I actually know what content I want to have zoomed here. So I'm actually going to set an attribute that allows me to specify which section of the page is going to zoom. So in this case, I'm zooming in right in on that center div. And as you can see, my header and the rest of my page is still in place. Turn it back off. Whole page zooms. Turn it on again, and just that center zooms. So again, this would be a lot of work to do with JavaScript, but it's fairly easy. We've added a few parameters here. In this case, all I'm doing is setting the content zoom to one container. So I'm specifying the container that I want content zoom on. I'm turning it on, I'm turning it off there to show you the difference. But I add that parameter, and it'll allow the zoom for that specific area only.
Oh, so all you do is type in.
Okay. So on top of pointers, and on top of the CSS, we also have gestures. Now gestures are very interesting because they take you a step farther than pointers. They give you the information that's on the screen, but they also interpret the user's intent. So if a user intended to have a tap on the screen, it'll tell you a tap. If the user intended to have a swipe, it'll tell you a swipe. So I have a little demo here. The first thing I'm going to do is I'm going to show you pointers, and as I move my mouse, you can see a little trailing from the mouse pointers there. But I'm going to be using my fingers, doing 2 fingers across the screen, and you can see it's interpreting the width and the height of that pointer event so I can make it bigger or smaller. And those 2 fingers track as 2 separate events. So any method that I have on that move is getting fired twice because I have 2 separate events there. Now I'm going to move up to gestures. Now watch what happens when I do the same thing with the gesture. I just have 1 point because it's interpreting the user intent. The user is doing a swipe. So it's not telling you there's 2 swipes, it's telling you there's a single user gesture happening. Now also I can do a rotation, and instead of reporting back my 2 fingers, it's reporting back the rotation. So at that time it's telling me what my expansion is, what the size of the rotation is, the type of gesture, the velocity, even things like velocity of my swipe can be reported there. And it's just basically interpreting what the user wants. Tap and hold, all gestures, as opposed to 2 separate events that's fired whenever I have a pointers. So we have some very granular detail, and I want to move on to my final demo here. And I'm gonna, sorry about the pop. Okay, so this is a demo that we built, and what I wanted to highlight is more than just a game. It's about productivity. It's about actually producing something with your hands. So have any of you ever seen Nevermind the Bullets, the website? Okay, I have it here. So Nevermind the Bullets was a website that Microsoft built a while ago that kind of takes you through a parallel or a parallax environment. You can read the story, and it'll go through interesting effects. And then there's a version that kind of lets you build your own. Well, what it didn't really do is it didn't really give you any control over the characters. It just kind of let me add some bubbles in and stuff like that. So what I want to do with this version is kind of reimagine that and say, okay, I want to give full control over creating an environment for my Nevermind the Bullets here. So what I have is I have a timeline at the top of my screen here that's going to be going. I've got some layers here on the side, so you can see these layers I have over here. And then I have some tools at the bottom. So the first thing I want to do is I'm going to hit go, and it's just going to start playing. It's going to start playing through the environment. And then I'm going to do a scroll over and start back over the beginning because I'm going to actually add a little bit of motion myself. So I'm going to hit go, hold down the background, and then I'm going to start moving the background. It's a little jumpy here. Okay. So I'm going to go ahead and stop it, rewind it, play it. And you can see it's going to be moving my background. It's just remembering what I had added to the script before. So playing through that, I'm going to start over again. And now I have a little bit of air or pollution here I want to kind of add as an effect. So I'll be moving that with my fingers as well. And it's just playing what I had done the last time down below, and then it's adding this on top of it. Okay, and then I'm going to rewind. I can go, I can play it and see those things play together. Rewind. Add another layer here. I'm going to kind of move my town a little bit. Move it up a little. If it's going off in the distance. And again, if you notice, I'm doing a lot of multi-touch here, right? And it's not so much that I have different gesture that going on. I'm actually using 2 different touch points on the screen for 2 very different things. So it actually really helps to not have to look at the arrays, because over here I'm touching controls, and on the other side of the screen I'm actually creating the paths that I want. So I'm going to add the cowboy on top of this, and he's going to start walking a little bit towards the door of the saloon. Last thing I'm going to do, I'm going to add the bird here. He's going to kind of fly down. And you can see, I'm not really caring about my timing so much because I'm looking at what else I did in the picture. And I'm just kind of adding this to the script. So I'm going to go ahead and rewind it. Now, work a little bit with tools here. Who in here has actually seen a bird? See, that's a test to see who's awake. We've all seen a bird. Come on. Well, as you know, birds don't really fly that straight, right? So I wanted to add a little bit of with my rotation tool here, I want to kind of give him a little bit of wave as it goes through, floating down through the air. All right, rewind it. Now the one thing that kind of bothered me when I first did this is my background that's supposed to be that smooth pan is kind of jumpy. So I have another tool to kind of help me out there, and that's going to be my Y lock. So what I want to do is I'm actually going to turn on a Y lock by sliding my finger across the button. So it's going to interpret that user action, and that's going to lock the Y position so that it won't go up and down, it'll just go one way. So I'm going to go ahead and do that, and you can kind of see the bottom, my little Y lit up. And even though I'm moving both X and Y, it's just and my screen's a little jumpy, I think my fingers are a little moist, but so there we have it. We have an end product at the end. Get rid of my tools, and you can basically see I've made my own environment here. I've created a scenario right here in a few seconds just by overlaying one action on top of another, working with those touch points. So we kind of put it all together, and you can see how flexibility really plays into this. Whether it would be with my mouse, or whether it would be with my fingers, or whether it be with my stylus, I can use whatever tools make sense to me for that particular action to create this. So what I want you guys to walk away remembering is that there's a whole new world of flexible devices coming out there. And we want applications to be able to not only use that flexible model, but also accentuate it. Find ways to make it special in your application. And also, go to the W3C site for a pointer specification and contribute. Tell us what you want to see. Tell us what you like. Tell us what you're missing. I think I'm out of time, but I will stick around for any questions. Thank you so much for coming today.